In 1.3, we are going to look at physical and chemical properties and changes of matter. Properties of matter can be divided into two parts: chemical properties and physical properties. Chemical properties describe how substances react with one another. Chemical changes that occur in these cases are irreversible, and the original composition of the matter has undergone change. For example, when something reacts with an acid, it's no longer that substance. Or it reacts with water or oxygen or bases, same thing happens. And if something is flammable, catches fire or not, is also a chemical property. Physical properties can be observed while something is not reacting with anything. For example, is something undergoing a physical change like solid to liquid, liquid to gas, gas to solid, and so on. So these are all reversible, and the original substance still remains the same. Its chemical composition is unchanged. Physical properties can be further divided into two: extensive and intensive properties. Extend meaning make it bigger. Remember that. The extensive properties are properties that changes with the amount of matter, like mass, volume, and length. You can have, say, gold. A small amount of gold has a small mass. Small amount of gold has a small volume, and the piece would have a small length, and so on. Intensive properties depend on internal properties of the substance, the type of matter, the type of element or compound you're looking at. For example, boiling point of alcohol is much lower than the boiling point of water. Color, shine, melting points, freezing points, compressibility, and density of substances is also the same. You need to remember that density of substance is how dense it is. It's calculated by dividing its mass in grams by volume in milliliters. So, chemical properties of matter. First topic. So here are some chemical properties: toxicity, reactivity, heat of combustion, chemical stability, and flammability. As we described earlier, they are describing chemical changes. These are not reversible, and the composition of the matter changes after the reaction. An example of this would be burning wood, and in the end, you make carbon dioxide and water, and they evaporate, and what you have left is charred wood, which is black, or you can call it coal. It becomes just carbon. So here are some physical properties of matter, intensive and extensive properties that we discussed. Take a look at it. Here are some examples of physical properties. Physical state, ductility. Now I'm going to explain this one. It means if you can stretch something into wires. Malleability, can be hammered into shapes. These two depend on the type of substance. So these are intensive properties. Melting point, boiling point, these are the definitions. It's the temperature at which something melts or becomes a liquid. Boiling point is the temperature at which something becomes a gas. These are all internal. Electrical or heat conductivity, it means can you transfer electricity from one place to another, or the same with can you transfer heat. So for example, wood is not a good conductor of electricity or heat. So if you make a pot, it's a good idea to have a handle with wood. Or if you have a electrical implement, you want to have a handle in wood or plastic. Solubility is a substance dissolving in water or not. Compressibility is, can you squish it? For example, gases can be squished and solids cannot. And here is a calculation of density, which is an intensive property. So say something has a mass of 60 grams and a volume of 20 milliliters. Its density is 60 grams divided by 20 milliliters, right? So your units will be grams per milliliter, and in this case it will be 3 grams per milliliter. Topic number 2. Let's look at physical states and their transitions. You should be able to draw models of solid, liquids, and gases. So if you put a square sealed container and a solid into it, the solid has a definite shape, right? And the liquid has a indefinite shape but a definite volume. This one also has a definite volume. Gas has an indefinite shape and an indefinite volume because it takes up all the space of the container, and depending on the size of the container, its volume would change. So let's look at the transitions, the changes from one state to another. When a solid becomes a liquid, it's called melting. When a liquid becomes a gas, it's called boiling or evaporation. On the reverse, when a gas becomes a liquid, it's called condensation. When a liquid becomes a solid, it's called freezing. You can go from a gas directly to a solid. This is called deposition. For example, when dry ice, which is solid carbon dioxide, it doesn't melt, it just becomes gas. It goes straight from solid to gas. And a solid can go straight to gas. For example, when the Hiroshima and Nagasaki bombs exploded, some solid objects, because of the sheer amount of energy, solid objects that were near the site of impact, including people, they went straight away into the gas state. More on that later. So, energy also plays a part in this transition from phases. So all the red arrows show energy being absorbed. So kinetic energy being absorbed or heat energy being absorbed. So when you go to the right side, there is more energy. And then when you cool off or lose energy into the environment, you go in this direction, the blue arrow. So remember that as energy is increased or gained, the motion, kinetic energy of these particles, which are either atoms or molecules, also increases. So the highest kinetic energy is in gas, second highest is liquid, and the lowest is solid. Doesn't mean solid is just stable. It is moving but very slow. And the lowest kinetic energy lowers when you go this way. So let's look at characteristics of the three physical states based on shape, volume, motion of particles, and compressibility. Solid has definite volume and shape, very slow vibrations or kinetic energy, and it is weak, very weakly compressible. You cannot really squish solids. Liquids, they take the shape of a container. They don't have a definite shape, but they do have a definite volume. Think of a glass of water. It takes the shape of the glass, but its volume is either 20 or 100 milliliters, depending on how much you put. That doesn't change. Motion particles freely move sliding past each other, which is why you can pour a liquid and the particles are attracted to each other. That's why they stick together and not evaporate. And the compressibility again is weak. Finally, gas, it too does not have a definite shape. It takes the shape of the container. Volume, it takes the volume of the container and does not have a definite shape. And gas particles move rapidly in random motion. There is little or no attraction to each other. And because they are so far apart, the compressibility is high, which is why they take the shape of the container. So let's look at a review of this lesson. So we are able to identify and draw models of the physical states and then compare and contrast the states of matter, solid, liquid, gas based on volume, shape, compressibility, space between particles, temperature and motion. Identify and describe the characteristics and transition states of matter based on energy gain or release. Explain how chemical reactions cause chemical changes to matter, and explain how physical reactions cause no chemical changes and no changes into the matter. Compare and contrast chemical and physical changes. And that's it.